My name is Stephen Prager. I am the director of the Appleton Whittell Research Ranch of the National Audubon Society. We're managed by Audubon Southwest, and we're located about 60 miles southeast of Tucson. First off, I just want to thank everybody for being here for the second episode of this year's two-part series, our Appleton Whittell Research Fellow Lunchtime webinars. I'm excited to dive in and hand it over to our speaker, Sanchez, today. But before we do, I just want to go through a few housekeeping things. First off, this presentation is being recorded, and we will share it on our social media, YouTube, website, places like that. You'll notice that you're muted, your cameras are off, and that the chat is disabled. That's also, we can just avoid any distractions for our speaker today. But you do have the option to enter questions into the Q&A. You should see a Q&A icon somewhere in your Zoom window. Go ahead and click on that, and it will open up a place that you can enter questions that we will answer at the tail end of the presentation. And yeah, I think that's it. So if Heaven, you could go ahead to the next slide for me. Cool. So before we talk about Heaven's work, I want to just really quickly talk about the Appleton Whittell Research Ranch Fellowship Program at large. This is a program that was launched by the Research Ranch in 2010, and it encourages students, young scientists, to apply for up to 3 fellowship positions that we offer each year. Those that we select are early career scientists, usually between the ages of 18 and 30. They're focused on conservation-related questions that can be answered on the Research Ranch or in southeastern Arizona. And they're folks that show a strong commitment to conservation and a strong commitment to conducting sound science. So this year, we were able to award 2 students with fellowships. Each received $3,500 in cash to support their research needs, everything from equipment to food and travel, anything they need to get their season rolling. And then another $1,000 in the form of a Research Ranch housing voucher, and that provides free stays for our fellows, their friends, family, research helpers, anybody that's coming out in the field with them. And then lastly, our fellows get some communication support from our Audubon Southwest team. Things like this webinar today, also articles on our website, posts on our social media, lots of stuff to really get their faces and their work out to a broader audience. So one more slide. So what you're really here for today is not to listen to me ramble about our programs, but to hear from our fellows themselves about their work. So one more click, Heaven. There we go. So if you joined us yesterday, you heard from Matt Jenkins. He's a PhD student out of the University of Arizona, focused on azure and western bluebirds. If you missed it, again, these are recorded. It's already up on our YouTube. So after this, you can go and check that out. But today we're focused on the work of Heaven Sanchez. She recently graduated from an accelerated master's course out of Arizona State University. And she is focused on unraveling some of the questions around our priority grassland sparrows, focused mostly on the Botteri sparrow. And to answer these questions, she's been putting a technology known as Motus to work for the first time here on the Research Ranch. She graduated, I think, about a year ago now, but she continued.
I graduated in the spring.
In the spring, that's right. But she stayed on through the summer, even though she was done with her degree. And I really think that shows just her commitment to the work and to the project and to science and learning. She's pretty awesome. So without anything else, hand it over to you, Heaven.
Thank you, Stephen, for hosting me. And also, I want to thank everyone at Autobound. I want to thank Erica and Suzanne for supporting me. And I also want to thank everyone for attending today. But like Stephen said before, my name is Heaven, and my project is basically employing Motus to understand grassland sparrows' movements. So I think a lot of us are well aware of biodiversity crisis of species, which includes uh, attacks of birds, as you see here. This means that there has been an extinction of many species within the last 500 years, while birds is one of the highest taxa um, just being extinct within these last couple of or last 500 years. And with the biodiversity crisis, it's not just about the loss of species, but it's also the decline of population numbers. So at least 3 billion birds have been lost, with 1 in 4 breeding birds have been lost within United States and Canada. And then 1/4 of the loss of population within the last 50 years. 70 species have collectively lost 2/3 of their population within the last 50 years, and we are expected to lose another 50% within the next 50 years. Birds across the United States have shown a downward trend, except the wetland habitat. One of the habitats that we see a downward trend will be forest birds, shorebirds, and then the one with a significant decline would be grassland birds, where we can see on this figure, there has been a decline of grassland birds by 53% since the 1970s. So what are some drivers that these grassland birds have a decline? One of them is habitat loss, unsustained grazing, climate change, development, invasive species, as well as natural causes like fires. And within Arizona, it's this a large amount of grassland, and sadly, 2/3 of Arizona grassland are degraded. So this degradation has brought a decline within our state grassland, which have affected many species, as these species shown on here. And what affected conservation within these species, there is a lack of understanding of seasonal movements as well as their breeding ranges and when these species arrive, as well as the departure time. I don't know what happened there, but some specific issues that we see with uh, these birds are one of them being the Botteri sparrow. We thought it will draw to the south, like going to Mexico. And then we also see that these birds are not being recorded at all during winter seasons. So if you can stop here, we see them on eBird. In fact, we see them from May through September. While for castings, we see them around July through September, and then grasshopper sparrows we see from around late July through August. But this is where we're trying to figure out if these birds are here all year round, and or they're just migratory, and two separate groups are migratory to different places. And for the casting sparrow, we want to understand the annual distribution of fluctuations, such as the monsoon season, since these casting sparrows heavily rely on monsoon. And all these species, the late breeding season sometimes can mean these species are often unaccounted for through surveys, such as the Arizona Breeding Atlas, as well as other surveys that we have.
Hey, Heaven, I'm gonna interrupt you really quickly. Your internet is lagging a little bit. It might help if you turn your camera off. Cool, let's give that a go.
All right. So starting here, traditionally, we have these seven shortfalls in our current biodiversity knowledge. The lineage shortfall, which means we don't know all the species that exist on Earth. The Eleton fall, which is basically we don't know how species interact. Wallachian shortfall, we don't know where these species live, but we are coming up with a new shortfall that better understands our sparrow, which is called the movement shortfall. And this is basically the lack of detailed knowledge about full annual cycles and migratory patterns of animals, which hinders their conservation and management. So if you can see on the bottom left, this is a Botteri sparrow. Movement or range geographically. Next is Cassin, and then lastly is grasshopper sparrow. So based on these maps, we have little knowledge where, especially where the Botteri sparrow do their breeding. It just shows that they're at these places year round. But based on eBird that we were seeing before, it shows that they're only here during the summer months. So that is what we're trying to figure out here. And we can figure that out with a new technology called Motus. Motus is basically the Latin word for movement. And this actually first started in Canada. So what is Motus? Motus is basically an international research community which works together with movement and behavior between insects, bats, and birds. And where we first start, it would be the collaboration. This is where we understand birds and what birds we want to see, what birds we're trying to figure out, and we just start at collaboration. And then here, this is just our Motus station here at Appleton Whittell Research Ranch. I can see on here, it's not the whole windmill being our station, it's just this little portion that is our antenna, which detect the birds. We basically repurpose the windmill to have the antenna with the power box and the source being a solar panel. This Motus station could be basically placed anywhere. It could even be in your backyard. It is very simple to have and set up. And if you want to learn more about birds in general, or see what birds are in your backyard, you can have a Motus station basically in your backyard. So our station, like I said, is at the Appleton Whittell Research Ranch, and this station can detect nanotags from 15 to 20 kilometers, which is about 10 to 12 miles away. But the range, it varies greatly, such as from vegetation to topography, as well as height. and also the tagged animals. So Motus overall, there are over 4,500 stations worldwide, from Canada to United States, Mexico, as well as many of them being in Europe. As you can see on this map, there's a lot of the stations are in Eastern United States. And these yellow dots and or different color dots just represents the frequency of the Motus station. So 10 to 12 stations that fall within these three target grassland species range can really depend on where these species go. But in order to detect these species, each of these species or individual have to have a nano tag or a transmitter. This is basically a transmitter that's going to be with these birds for the rest of their lives. So as you can see on here, this is the solar panel. So where they charge and they have a lifetime of battery. And also if you go a little bit up, it's not shown in this picture, but that is the signal where it communicates with the Motus tower as well as nodes. And here it just shows that us putting on the transmitter. So here, when we put on the transmitter, we make sure it's around their wing and their legs. So, but it's safely on there. And these nanotransmitters are actually 3% of their body weight. So it's just like a small backpack that they really don't really notice. And here you can see on here, there's like a popsicle stick. We just wanted to make sure that it is tight enough for the bird to have a long period of time, as well as loose enough so that the bird is very comfortable. So, the Motus station, once these birds have the transmitter, they can be detected by any Motus station within the country. There is one Motus station in Patagonia. So, one of our birds can fly to Patagonia and be detected there. I know their range is close to our range. It will be like this kind of circle. So if a bird were right here, it can be detected by both Patagonia and our tower here. And then with Motus, there is a nodes, which I like to call them mini Motus towers. So a node is basically, it also detects birds that has these transmitters. And as you can see on this figure here, these red triangles are the nodes, and they can all signal or all detect a bird that's within their vicinity. So if a bird were to move all the way up here, then these two nodes will be able to detect, and this node down here can detect the bird that's up there, but it will be at a lower frequency, meaning the distance is very far. And with these nodes, we would want to figure out where these birds are exactly, what time of day, as well as coordinate where exactly their territory size are. And then here is a little better example. This just represents a potential territory size. So if these birds were to move over here, so these nodes won't be able to detect the bird over here. But if it were to come to the vicinity of these nodes, then it will be easier to detect. So our primary objectives for this project was to determine if seasonal movements occur within these populations, such as if these movements occur, we want to identify the timing of these movements as well as locate where they spend majority of their time within these location and the period of the year. We also want to assess if Motus is an effective method for tracking grassland birds and develop a set of best practices moving forward. So, meaning since these grassland birds have short distances, we want to make sure that Motus is a good technology for us to use to measure these short uh, distances. And then we also want to advance our understanding of these small scale movements of birds within these grasslands. So we started this project in the summer of 2024, around late May. The Motus Tower was already there. We just wanted to use these nano tags and tag at least 5 individuals of each species. So we wanted to tag 5 Botteri sparrows, 5 Cassin sparrows, and 5 grasshopper sparrows, as well as place nodes on the ranch to identify small scale movements and what habitat these birds like to be in. So for the results, there was a total of 16 grassland sparrows being tagged. 17 of the or 17, 7 of them were Botteri sparrows, 4 being Cassin, and 5 being grasshopper sparrows. And by the end of the 2024 season, there was a total of 14 grassland sparrows being detected. 2 grasshopper sparrows were not detected at either the nodes or the station. And as of late August of 2025, we have determined or found that 2 Botteri sparrow that were tagged last year were detected this year, meaning that they returned. So this is just a graph showing the tagged grassland birds detected on the Appleton Whittell Research Ranch. And this first section, um, it gives both the Motus station and nodes detections. So here on the x-axis, we see the date. So we just started late May, and each day or each every 2 weeks we tag more and more birds. So each of the numbers fluctuate. But by the end of or by mid-August, we officially tagged 16 birds. And on here on the x-axis, we just see the dates from June of 2024 through August of 2025. And here's January of 2025, which is the new year. And then on the y-axis, it is the number of individuals being detected. So note there was a possibility of having 16 birds being detected, while our most detection was 6. The orange represents the Botteri sparrow, while the green represents the grasshopper sparrow, and then the blue represents the Cassin sparrow. So our most detection in one day was 6, 3 being the Botteri sparrow, and then the other 3 being the grasshopper sparrow. Just note, the summer of 2025, we have not yet analyzed the data on the nose. So this is just the Motus station itself. And so far we had 2 birds, 2 of our Botteri sparrow return, as well as us tagging more birds this season. And this, even after August, we still are having more detections. But yeah. And then this is just our methods of detection. So a total of 14 birds were detected. 10 individuals were detected by the station. 8 individuals were detected by nodes only, and 4 individuals were detected by both stations. So within the breeding season of 2024, 72% of the detections were only registered by the station. 28 detection were only registered by the nodes, while the other 28 were detected by both the nodes and the Motus station. And then here is just a map of the Appleton Whittell Research Ranch. So this green triangle up top, that is where we have our Motus station. And then down here, these green rectangles show each of our nodes. So in total, we had 6 nodes about 500 meters away from one another. And then the bright yellow star represents the birds that were detected by both the Motus station as well as the nodes. This is just where we captured them, but we don't know where exactly were they gone. And also the orange star is the birds that only detected by the station only. So it's these guys. And then the blue star is birds being detected by nodes only. And then the 2 grasshopper sparrows that were not detected by either the station or the nodes are located up here by this yellow star. So in summary, birds and the Appleton Whittell Research Ranch appear to have a seasonal movement where their arrival and departure dates are still being determined. Motus has given us mixed results in detection, which highlights the shortfalls that is needed to address before fully being reliant of remote tracking for conservation efforts. And in the future, we want to promote the development of the station in areas where these sparrows might be wintering, as well as track small scale movements with nodes and compare them with field observation data. So during my time or this last summer, I created territory sizes just to compare them with technology and see if it was accurate or we need to switch or determine which is better for these grassland sparrows. And then we also use nodes to identify movements of grassland sparrows responding to management practices on the ranch. So if we can see on this bottom map, the blue that is highlighted is the treatment area that is already been in place by the Appleton Whittell Research Ranch. I just want to thank everyone who contribute to this project. I know science is very collaborative, so I want to thank both Adams, Chrissy, Nick, Edwin, Matthew, Stephen, Sid, Simone, Kyra, Emily, Livia, Keith, Aya, as well as my family, Elohim and Angel, and my mom. And I also want to thank Arizona State University, Game and Fish, Snore Joint Venture, as well as Appleton Whittell Research Ranch. And then I will take questions.
That was awesome, Heaven. It's been such a pleasure having you out here the last 2 summers, and I don't know that you fully appreciate yet, but what you've done helping us explore this technology opens so many doors for us. So we're going to be singing your praises for a long time. So yeah, if you have any questions, go ahead and drop them into the Q&A box. I'm going to go ahead and read those out and let Heaven respond. We'll take them one at a time as they come in. So first off, Evan, does a node need to be within a maximum distance of a Motus tower? And does the node have a similar detection range as the tower?
So no, a node does not need to be within a maximum distance of a Motus tower. In fact, if a node was very close to a Motus tower, it can also give data to the Motus tower, and it will go to the community Motus website where you can see what are basically see the birds being detected by the nodes. But here in our project, we placed these nodes very, very far away where there was no signal for the Motus tower to connect with the nodes. So therefore, we were manually collecting data from each nodes itself. And then for your second question, does the nose have a similar detection range as the Motus tower? It does not. The range is about 500 meters per node. And in fact, some of these nodes can communicate with each other and determine where exactly these birds are at.
And that's one of the things we're most excited about here is that through this work, we learned that if you have a stash of Motus nodes, you can put a remote monitoring array anywhere, which is pretty cool. Next question. Do you know how much the nodes cost, Evan?
I know how much the transmitter costs, but not the nodes, because I did not purchase them this season. I only purchased the transmitter. And just for the transmitter, if anyone was curious, each one was about $400.
Cool.
So I did
Yeah,
not know.
those nodes were contributed to us through some help from the Arizona Game and Fish Department. I would have to dig around to figure out what the cost was, but you should be able to look it up. They're put together by, I believe do you know if they're low tech or the other one, Heaven? I can't remember. What are
I
our
think it was like
tags?
CTT
Right,
technology website.
CTT makes the nodes. That's correct. So yeah, check them out and you should be able to find the answer. Let's see what else we got. Sorry, I'm just kind of scrolling down. There's a lot of praise for you, Heaven, and some repeat questions.
Oh, thank you.
What was your favorite experience while doing this work, and what do you plan to do in the future?
My favorite experience is just being out there in nature. I love listening to the Botteri sparrows. Even if I wasn't doing my territory sizes, I just love listening to them, and it just made me appreciate nature in general. Because I am from a rural area down in Yuma, so I'm not used to seeing all these birds and coming down to the Appleton Whittell, it just made me experience like have a new appreciation of these birds. And I also appreciate the people who went down with me because a lot of times we did not have service, but we just made the best out of it.
Do grassland sparrows come up to Phoenix? Is there a Motus station in Phoenix? And I guess if you could explain like kind of the benefit of a station versus a node.
Yeah. So a station versus a node. So a station will basically detect a bird one time throughout the season. So if it was detected twice in one day, it will only show one detection for the Motus station. While for nodes, it will detect what time, what day, and also where exactly these birds were being detected. So it's very different, but it still gives us like if a bird was being detected or not. And then what was the other question?
Um, they wanted to know if there's a station up in Phoenix and if the grassland birds make it up that far north.
Gotcha. I know we are in process of make or creating a station by ASU Poly, but I don't know if there's one in Phoenix, like Dead Center Phoenix.
I'm not
And
sure.
then
Folks could go onto the site and check out that map. You'd be able to see any stations near you.
as far as I know, grass or we're saying grassland sparrows or grasshopper sparrows.
They asked grassland sparrows in general.
Okay. So grassland sparrows, they're based on Motus detection, and there was none up in Phoenix, as well as eBird.
Yeah, they'd be hard to come by up there. Um,
Yeah.
Go to the next one here. Attaching the monitoring unit to a bird must have been quite stressful for them. What, if anything, did you do to mitigate their stress? And did any birds get sick or run into trouble soon after being tagged?
So when we tag them, we focus on the bird first and foremost. So when we first capture them, we make sure we were in the shaded area. We tagged them. We also put in the transmitter as well and make sure they were breathing right. If a bird were to have their mouth open, that gives us a sign that is like overheating. Sometimes we just let them go and try to catch another bird, but other times we try to wrap it up real quick and try to minimize the stress on each individual that we captured.
Yeah. And to the second part of that question, did any birds run into any issues immediately after being tagged? It's kind of hard to know. There were a few birds that we haven't redetected. Um, but it
Yeah,
seems
it's hard
like
to know. But also, there was this time where we accidentally recaptured a bird and it looked like it was doing well with the transmitter. It didn't have any issues. It didn't seem to be injured of any sort. It was just living its day and getting recaptured again.
yeah, yeah, they seem to do pretty well. Let's see what's next here. Did you notice any changes or factors that could affect why the Botteri came back a month later in 2025 than they did in 2024? Did rain come later in the season, or do you think they were just breeding later?
So the particular individual that returned, that bird was being detected a lot during the 2024 season. In fact, it was being detected when we first banned it all the way through September, and it's looking like the same process that it was first detected in mid-May, disappeared for a bit, but was getting multiple detections by mid-June or early June, and it's still being detected right now. But that is just one individual Botteri sparrow, and we are still figuring out if they were here during early June through nodes. So that is just Motus itself being detected. We haven't looked at the nodes yet, but that individual was being detected by nodes from last season 2.
Right on. And I'll add to that. Our rain did come late this year. We were really dry until about halfway through the monsoon. Um, and the Botteri sparrows are still singing right now. So it does look like they may have gotten off to a late start. Mhm. There's one in here from Yuma Audubon. If you ever find yourself out that way, they would love to have you out to give a presentation. And they're a
Oh,
great
thank
group.
you.
If you want to be connected with them, I could do that.
Thank you. Ask my grandma if I can crash in her couch.
I bet she'd say yes, knowing Nancy. Let's see. We had the same question for Matt yesterday. Did you experience any personal growth or development through this experience? Any impacts on your personal future aspirations or professional career trajectory?
Yeah. So, uh, just technology itself, technology really changed my perspective of technology. I never thought I would be good at technology until I tried out this boat stuff. And I really want to use Motus for my future career too. So I don't want to give up mode in general. Um, I do want to expand mode to other species as well as setting up more stable United States as well as other parts of the country like Mexico. I feel like that is for me to handle in the future.
And you you hit on it a little bit there. But what other species would you like to apply Motus to?
Ooh, that's a good question. I'm a waterfowl gal, and I like to apply this to ducks and geese. So maybe those guys.
Cool. And here on the ranch, I've got my eye on Montezuma quail, especially with those nodes. This is an easy one. Is there a way to ID each individual bird? I.e., is the transmitter attached to an individual, like each code?
Yeah, everyone has a different code.
Yeah, we're able to track each tag has its own individual radio code associated with it. And I think you talked through this, but the last question I'll give to you, I'm going to take the last one here, is how is the transmitter affixed to the bird? So if you could just talk a little bit more about those little backpacks we make.
Yeah. So each transmitter, they're basically 3% of the bird's body weight. And we have it's hard to explain this, but it's basically four loops. One loops goes to their shoulders, which is around their wings, and then the other two loops will go around their legs. And then we just tie it at the top or where their back is. And then we make sure it's secured while they have extra space to move around. And then when we make a knot on the string, we will glue the knot together so it does not while they are flying. And then we make sure that it burns. So I know we were using a Yagi at the time to make sure it was that we just the bird.
Yeah, they're a neat little homemade harness. Um, and the last one here that we're going to take, and then we'll go ahead and sign off. Of course, thanks you for a great presentation, Evan. And wants to know if there are plans to expand the network of nodes on the research ranch or elsewhere in the region. And on the research ranch, yes, absolutely. What we learned from Heaven's work about the potential of these nodes just has our wheels spinning about all of the questions we can ask. So stay tuned for more. And yeah, thank you again, Heaven, for the work, for the presentation, for teaching us a whole heck of a lot. We really appreciate you. And thanks everyone who joined us today. We hope you have a great afternoon and rest of your day.
Thank you, everyone.